This is question 8 from this paper here. So this paper is the 2023 CCEA Pure Maths A2 paper. It's from June 2023, as I say, and that's question 8 we're looking at, which is mostly a bit of calculus, generally differentiation here, with a bit of implicit then to start. So a curve is defined by this equation here. Find dy by dx in terms of x and y. So we need to differentiate each of these terms, and we're going to do that then implicitly. So the bit that's a little bit messy, the fly in the ointment here, is this one here. So we need to, I'm going to take this bit out separately and try and work out first of all d by dx of 3x y, and I'm going to use the quotient rule then to work this one out first of all. So I'm going to let my u equal 3x and my v equal y. So my du by dx then is a 3, and my dv by dx then gives me dy by dx. So it my formula then for dy by dx is going to be v du by dx, so it's 3y minus u dv by dx, so that's 3x dy by dx all over v squared, which then is my y squared. So I'm keeping this wee bit off to the side, and now I can go about then kind of differentiating this here. So my 3y squared is going to go to 6y dy by dx. Plus 2, and then it's minus this big lump here. And then that 5 then just goes to a 0. Hopefully you could just about see that there in terms of what we have. A couple of different ways I can attack this. I'm going to multiply through everything then by y squared. So be careful you do this term, and obviously this term then gets rid of the denominator down here. So that's going to give me 6y cubed dy by dx plus 2y squared. That's going to be minus 3y plus 3x dy by dx equals 0, and we're almost there. So we just need to rearrange now and get dy by dx on its own. So I'm going to get these two terms stay on this side, take these two terms over to this side. So if 6y cubed dy by dx plus 3x dy by dx equals 3y, so minus 2y squared. I now factorise out the dy by dx. And divide by the bracket, and that's me done. That's us. On then to part B. Consider the curve with equation y equals 3x e to the 2x. Find the equation of the tangent to this curve at the point where x is minus 2, giving your answer in the form e to the power of a y equals bx plus c. So obviously we need to differentiate here, and this is going to be a product rule question. So u I'm going to write down as 3x, v is e to the 2x, du by dx is 3, and dv by dx is 2e to the 2x. That gives me then dy by dx, which is 3 times e to the 2x, so it's 3e to the 2x plus 6x e to the 2x. You can do it a couple of different ways. You can tidy it up as well if you want. It just might make things easier whenever we sub them in. So there's a common e to the 2x, and there's a common 3 can come out. So if I go 3e to the 2x, then upon 1 plus 2x, and we end up then with that. So it says find the equation of the tangent to this curve at the point where x is minus 2. So if I let x equal to minus 2, that's going to give us then the gradient that we want. Then dy by dx is equal to 3e to the minus 4 all upon 1 take away 4. So that gives me 1 take away 4 is minus 3, obviously. So it's going to be minus 9e to the minus 4. I could rewrite that if I wanted as minus 9 over e to the 4. So what's that? That's the gradient whenever x equals 2. We need to find in the y coordinate whenever x is minus 2. So if x is minus 2, we're going to have y minus 6e to the minus 4. And again, that's minus 6 over e to the 4 if we want to write it like that. And that's fine. So here's a couple of different ways. We can do y equals mx plus c, or we can go y minus y1 equals mx minus x1. So for this, I'll just go y equals mx plus c. Y equals minus 9 over e to the 4 x plus c, and I'm trying to find my c, and I know the point minus 2 minus 6 over e to the 4. So it's minus 6 over e to the 4, and then minus 2 times that gives me 18 over e to the 4 plus c, and that means in my c is minus 24 over e to the 4. So I can substitute this in. Y equals minus 9 over e to the 4x minus 24 over e to the 4. And that's effectively me done. However, they want it just in this form here. So I just need to multiply through then by my e to the 4. So that's going to give me e to the 4, sorry, you can't quite see that, e to the 4y equals minus 9x minus 24. Now, I managed to squeeze it all into one page. There was another page there if required, but that's okay. Let's take a wee look then at part 2. This curve has one turning point. Find the coordinates of this point and determine its nature. Okay, so to find the turning point, we obviously put dy by dx equal to 0, and my dy by dx, as we know from the previous part, dy by dx we'd written that as 3e to the 2x upon 1 plus 2x. So turning point when dy by dx equals 0. So that either means 3e to the 2x equals 0, or 1 plus 2x equals 0. 3e to the 2x, you can try and solve this whatever way you want, kind of divide through by 3, take a natural log, but there's no solution there. So that's kind of that one. And then rearranging this one, take the 1 over the other side, you're going to get x equals minus a half. So that's the one turning point that happens then whenever x is minus a half. So we need to find the coordinates of that. So to find that, we substitute it back into the original equation. Y equals 3xe to the 2x. So that gives me y equals 3 upon minus a half. Minus a half times that then is e then to the minus 1. That would tidy up to give me minus 3 over 2e effectively. So my coordinates then are minus a half minus 3 over 2e. You put that into your calculator and get a number out. I think it's like minus 0.552 or something like that. So we'll have to find that. We also need to determine the nature. So we need to then differentiate again. Now I'm going to do the multiplied out version of this. It's just more straightforward than whenever we're doing it. So dy by dx is going to be, let's see what I had, 3e to the 2x plus 6x e to the 2x, and I need to differentiate that again. So d2y by dx squared, that's going to give me 6e to the 2x, and then be careful here, this is now going to be a product rule again. You could set it off to the side if you're not so sure, set u to be 6x, set v to be e to the 2x, but I think we should be able to work it out here. So it's this times this differentiated, so this differentiated brings a 2 to the front, so it's going to be 12x e to 2x, and then e to the 2x times this differentiated, so it's just going to be plus 6 e to the 2x. So yeah, that's us. That tidies up with 6e to the 2x here, with 6e to the 2x here, and so that gives us 12e to the 2x plus 12xe to the 2x, which again, if you wanted, we could kind of factorize out. There's not really kind of too much going on there, and that's fine. We want to find in the nature of the turning point, so whenever x is minus a half, d2y by dx squared, we stick minus a half in there, and the minus a half, don't be put off by the minus, that doesn't turn it into a negative. The answer then is greater than 0. That means it's going to be then a minimum, so therefore it's a minimum point at minus a half. What was my y coordinate then? Minus 3 over 2e.